Oh, the good old difference quotient. That's what we're doing on this one. We're finding the difference quotient for each of these functions. This is essentially the difference quotient. Essentially, it is. All right, so essentially it is the slope. You know where you subtract the y's on the top and you subtract the x's on the bottom? That's what the difference quotient is. It just looks a little different, a little weird. So let me show you guys why it looks like that. So you guys know that if I went f of 5 minus f of 2, those would be two different y values right there, and these are your x values. See, the x values are inside the function, which will give you your y values, okay? So now my slope kind of looks like this guy over here, but not quite. Let's change it up just a little bit. Instead of writing 5, I'm going to write 2 plus 3, and the reason why I do that is because there's a 2 in this one, and if I go 2 plus 3, I get 5, so 2 plus 3 gives me 5. And on the bottom, you have 5 minus 2, and you guessed it, if you go 5 minus 2, it is 3. So now you see that you got your two h's right here. The 3's, see the h's? You got the h on the bottom, the h inside adding to the x, and these are your x's. So here x equals 2 and the h equals 3. So that's just to help you guys understand what the heck a difference quotient is. Now let's take a look at B. All right, I think A is probably the more simple one and C is the most complicated. So I'm going to do the one in the middle. Hopefully you guys can do the other ones on your own. All right, so for this one, for letter B, what we're going to first do is we're going to take the x plus h and we're going to plug it into the g function. That's what this says. It says you take the f plus h, or x plus h, and you plug it into the function. Okay, so our function is g right now, so this is our rule for the function. So I'm going to go ahead and plug x plus h into it. That's what it looks like. Everywhere I see an x, I put an x plus h in there, and don't forget your parentheses. Next, I'm going to go ahead and throw the h on the bottom, so we're dividing by h in the end. Then I'm going to subtract. I'm going to subtract what? I'm going to subtract the next part. So this is the first part, the x plus h plugged into the function, that's that. Then I'm going to go minus, that's just the function with x plugged into it. And so actually x is already plugged into it, so I just have to write out negative 3x squared plus 7x plus 11. Next, let's simplify. So to start simplifying, I'm going to go ahead and I'm going to square the x plus h, and this is what I get, so fancy schmancy. And then I'm going to distribute the 7 to the x and the h, and then I have my plus 11. So that's the first guy, he's done. And then I have the minus of this. So I'm going to distribute this negative to each of those terms, and this is what I'm going to get. I'm going to get a positive 3x squared, a negative 7x, and a negative 11. Then I'm going to divide by h. Let's distribute this 3 over here really quick to be done with that distribution. And I'm not going to rewrite the whole thing. I'm just going to cross it out right there. And this is the best part. You get to find all the things, all the terms that cancel each other out. If you're doing the difference quotient correctly, you should be able to cancel out some stuff, like these 3x squareds and the x terms, the 7x and the negative 7x. And then finally, there's one more. Do you see it? Do you see it? Do you see it? There they are, the 11s. So let's rewrite what we got. We got negative 6h xh minus 3h squared plus 7h. We're going to divide each of those terms by h, each of them. This one divided by h, this one divided by h, this one divided by h. When I do that, this is my result, which is my answer. That's how you do the difference quotient with these bad mamma jammas.